You've seen pumps everywhere. Pools, fish tanks, industrial plants. They all move liquid, but how do you pick the right one? Choose a pump that's too weak and you won't get enough flow. Too strong and you waste energy and risk damaging your system. That's where the pump curve comes in. It's the pump's performance report card. Picture a graph. The horizontal axis is flow rate, how much liquid moves, and the vertical axis is head, how high the pump can push water. The main line on this graph, the pump curve, shows the trade-off. As flow increases, head decreases. This curve is based on real-world testing, not theory. Manufacturers test pumps at different flow rates and plot the results. For engineers, this curve is gold. It tells you exactly what the pump can do. Want a certain flow? Find it on the graph, go up to the curve, and see the head you'll get. The pump curve takes the guesswork out of pump selection. It's the first step to making smart, efficient choices. With the pump curve, you're not just picking a pump, you're picking the right pump for the job. It's the foundation of reliable, cost-effective systems. Master the pump curve, and you're on your way to being a pump whisperer. Now let's find the key landmarks on a pump curve. First, the shutoff head, where flow is zero and pressure is at its max. Don't run a pump here for long. It's like revving your car in neutral. Next, the best efficiency point, or BEP. This is where the pump works best. Maximum efficiency, minimum energy waste. The BEP is your target for reliable, cost-effective operation. Around the BEP is the recommended operating range, a safe zone where the pump runs smoothly and efficiently. Stray too far from this range and you risk noise, vibration, and early failure. Finally, check the NPSHR curve. Net positive suction head required. This tells you the minimum inlet pressure needed to prevent cavitation, which can destroy your pump. Always make sure your system provides more pressure than the NPSHR. These landmarks help you avoid costly mistakes. Know them, and you'll keep your pump running strong. The pump curve isn't just a graph, it's your roadmap to pump success. The BEP is the sweet spot for any pump. At the BEP, your pump uses the least energy for the most work, saving you big on electricity. Even a small move away from the BEP means wasted energy and higher bills. But it's not just about money. At the BEP, the pump runs smoothly, with minimal stress on bearings and seals. Move away from the BEP and you get turbulence, vibration and wear, leading to breakdowns and expensive repairs. Pumps running at the BEP last longer and need less maintenance. That's why you always want your system's normal operation to match the pump's BEP. The pump curve helps you find this perfect match. It's the smartest way to save money, reduce downtime, and keep your system reliable. The BEP isn't just a number, it's your pump's best friend. Let's put this into practice. Imagine you're choosing a pump for a water treatment plant. You need 500 gallons per minute at 120 feet of head. That's your target duty point. You check pump curves from 3 manufacturers. Pump A can do the job, but your duty point is far from its BEP, inefficient and likely to wear out fast. Pump B can't reach 120 feet at 500 GPM, not powerful enough. Pump C's curve passes right through your target, and the BEP is almost a perfect match. That's your winner, efficient, reliable, and cost-effective. By using pump curves, you make a data-driven choice, not a guess. The right pump saves energy, reduces maintenance, and keeps water flowing. This is the power of the pump curve in action. It's not just a graph. It's your key to building robust systems. Choose wisely, and your plant runs smoothly for years. What if your system's needs change? Enter the Variable Frequency Drive, or VFD. A VFD lets you adjust pump speed, creating new performance curves for different flow demands. Instead of running inefficiently at low demand, the pump slows down and stays near its BEP. This means big energy savings and longer pump life. So, remember, always check the pump curve, aim for the BEP, and use a VFD for changing demands. The pump curve is your pump's DNA. Never select a pump without it. Match the pump to your system and you'll save money, avoid breakdowns, and look like a pro. For systems with variable needs, a VFD is the ultimate upgrade. Master these basics, and you'll build efficient, reliable systems every time. Next time you see a pump, you'll know exactly what it's telling you.